Okay, so in today's video, we're going to talk about layers of the Earth. This is the start of our new unit. It's my favorite unit. We do a lot of really fun hands-on activities. So here's our introduction. So layers of the Earth. There are two different ways to divide the Earth into layers. We can look at the Earth based on composition or based on physical properties. And there's two sets of layers depending on if you're looking at either of these. So the first one we're going to look at is composition. So the compositional layers are based on what elements each layer is made of. So if you ask what is something composed of, you would be saying what is it made up of. So composition or compositional means what's it made of. Okay. So the boundaries between each of these layers are very clear and well defined. And scientists know, or scientists have a best guess as to how the layers are formed and what's in them based on waves, like earthquake waves. So when a wave comes through one side of the Earth, they have a sensor on the other side of the Earth, and they see how the wave bends. Because if you know, when you shine light through water, it bends. And if you have sound through, air, it bends. So earthquake waves are the same way. So the earthquake waves bend, and they know, well, on the surface up here, if we put a wave through iron, it bends in a certain way. And when we measure these earthquake waves, they're bending the same way. So we're going to assume that that's iron because we've studied that up here, and we're going to assume the same thing holds true in the Earth. So when we look based on what the layers are made up of, those boundaries are very clear. That wave has a very different behavior, or it travels very differently through one layer than it does through another. So it comes through the first layer, and then it might bend very sharply into the next layer. So these layers are very clear, and the boundaries are very exact. The layers for composition from the outside in are the crust on the outside, then the mantle closer to the middle, and then the core in the very center of the Earth. So there's three layers. And if we're going to look at, if we're going to look at these layers, this is my very lopsided model of the Earth. The crust on the outside, remember we're looking at what the elements the layer is made up of. So these elements are calcium, the chemical symbol Ca, sodium, Na, and aluminum, Al. So that's what the crust is made up of. So that's one layer because it's made up of certain types of elements. The second layer, the mantle, which is this big section that takes up most of the Earth, is made up of iron, oxygen, aluminum, silicon, and magnesium. So it's a different set of elements. So it's composed of different elements than the crust is. And then lastly, the core, kind of like the donut hole in the middle, is made up of iron and nickel. Okay, so this is more rocky, calcium and sodium. This has a little bit more variety in it, and then the core is all metal. So that's the three different compositional layers. And to be honest, we're not going to talk about the compositional layers very much after now. Okay, so the other way to divide our Earth into layers is based on physical properties. And we talked about this in the chemistry unit when we talked about magnetism and luster and things like that. So physical properties are things that you can look at without changing the substance. So you can just look at it, you can cut it up, you can examine it under a microscope, stuff like that. So scientists look at the density, texture, temperature, things like that to determine what layers to divide the Earth up if we're looking at physical properties. So the boundaries between these layers are not really clear. They gradually change from one layer to another. So there's not that exact boundary. One layer kind of gradually turns into the other one, kind of gradually turns into the next one. So the boundaries or the dividing lines between our layers are kind of fuzzy. They're not real clear. So the layers from the outside in are the lithosphere, and then the asthenosphere, the mantle, which is the same. You may also hear this sometimes be called the mesosphere, but the mantle and the mesosphere are the same thing. It's easy to remember because they both start with M. So mantle, mesosphere, same thing. the outer core, and then on the center, the inner core, which makes sense because the outer core is the core on the outside, which makes sense. Okay, so here's a diagram of these layers. And again, the lithosphere is on the outside, then the asthenosphere. So this part in here is the asthenosphere. The mesosphere is this middle part, or mantle, the same thing. The outer core, and then in the very middle, the inner core. So the lithosphere, this first ring on the outside, is the outermost layer. It has a low density. So when you calculate it, it has the lowest number density when you divide the mass by the volume. It has a low temperature and a rocky texture. So this is the outside of the Earth where we live. And so it's very rocky, it's cold, relatively compared to the inside, at least. It's cold and it's not very thick. It's only between 60 and 300 kilometers thick. And we will learn in future videos that the 60 is under the ocean. It's the thinnest under the oceans. And the 300 is like mountains. So it ranges depending on what the surface of the Earth looks like at that part. So oceans, it's really thin. Mountains, it's really thick. The next part, this asthenosphere, this second ring, the red, this middle part, has a slightly higher density. So it's higher than the lithosphere, but it's still a fairly low number. It's a little bit warmer and has a gooey texture. So I like to say that it's kind of like peanut butter or like cake frosting, where it's a solid, but you can like move it around real easy. If you think of it, a asthenosphere is basically lava or magma. It's magma, lava, right? And it has that kind of gooey, warm, hot texture. It moves, but it's still a solid. And it's 250 kilometers thick. So it's thicker than some parts of the lithosphere, but not all of it. So this part is also fairly thin, the asthenosphere. And then this next part, the big purple section, is the mantle or mesosphere. And remember, these both start with M, so it's easy to remember. This is even more dense, so it has a higher density than the asthenosphere and the lithosphere, and it's hotter. So far, this is our hottest layer going in. It's hotter than both of these. Its texture is thicker than the asthenosphere, but it's still kind of gooey, like it moves around. And it is 2,550 kilometers thick. So this mantle or mesosphere makes up the majority of the planet. The inside of the planet is mostly this kind of thick, gooey, hot stuff. Now we're going to talk about the cores. My board doesn't fall on me. So the outer core is even more dense. So as we go in, the layers get more and more and more dense and hot. It's completely liquid. So it's so hot that it is completely melted. And it is 2,200 kilometers thick. So it's more dense than the mantle and the asthenosphere and the lithosphere. And it's even hotter. And it's completely liquid. That's the cool thing about the outer core. It's different than all the other layers. And then the inner core, the very center of the Earth, is the most dense. It's incredibly heavy and dense. So when you calculate its mass divided by its volume, it comes up with the highest number. It's like 15, 20, I don't know. It's a big number compared to the outer layers. And it's very, 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 very hot. Very hot. You don't want to go there. It is made of solid iron. So it is a solid ball of iron metal in the center of the Earth. And it is 1,228-ish kilometers thick. So it's fairly good size. The mantle is the biggest, and then the outer core, and then the inner core. Now you may say, well, what does density have to do with the layers? That's a good question. Remember, in our chemistry unit, we learned that if something is more dense, it sinks, and if something is less dense, it rises. Well, this has everything to do with the layers. The stuff that was the most dense sank to the center of the Earth. And the lithosphere, which is not very dense, rose to the outside of the Earth. So the layers are the way they are based on density. If the number is higher, it's going to sink and be at the bottom. And if it's lower, it's going to be on the outside because it's going to float. So the lithosphere floats on the outside of the planet because it's the least dense. So see, I come back full circle, bring back the fall. Remember, density, mass divided by volume. So here's our layers. There's 3 if you look at it based on what they're made up of, composition, and there are 5 layers if you look at physical properties.